Hello, everyone. Welcome to the Thomas Expert Series. Thank you for joining us today. We're going to get started in just a moment. Just please double check your microphones, make sure you're muted. This expert series will be recorded and placed on demand within 24 hours. So please let your colleagues know how much you enjoyed the presentation today and direct them to the On Demand tab to sign up or check out our talks or have them sign up for future talks. To get everyone started, let's see where everyone's tuning in from. I'm in New Jersey. Jesse, where are you?
Massachusetts.
Awesome.
Sunny.
Anyone in the chat? Got some North Carolina, Philly, Michigan, Charleston, Germany. Cool. South Carolina. Hopefully I see Michelle's in California, so hopefully she's getting the sun that we want over here, Jesse. And we've got Utah. Alrighty. I'm going to go ahead and turn it over to Jesse here to talk about realizing the power of air filtration.
Thank you, Heather. Appreciate it. Good afternoon, everyone. Happy Friday. I promise this is not going to be death by PowerPoint. We're just going to be as authentic as we possibly can be. But first, want to make a quick introduction. So Jesse Coral, Lab, been with the company about 14 years, director here, and really have focused my career on contamination control and environmental control services. So what Lab does is we provide contamination control solutions for the protection of laboratory personnel through the power of filtration. So everything you see behind me within our Inspiration Center is powered by filtration, meaning there is no HVAC necessary within the building at all with any of our products. So independent, completely flexible, and provide solution wherever the chemical needs to be within your organization. Some key benefits to this technology obviously is the flexibility. It's not tethered to the building's infrastructure, and the sustainability aspect. Why sustainable? Because we're taking air, we're conditioning the air that you're already bringing to your facility, and we're capturing at the source within molecular filtration or within our HEPA filters. And we're not throwing that polluted air out into the environment and therefore having to remake up already conditioned air, which is extremely costly. Our biggest product we have that I want to talk a little bit about today specifically is our ductless filtering fume hoods. Fume hoods themselves consume about 3.5 times of US homes. Filtered fume hoods, however, reduce the energy consumption by about 94% in energy and your overall CO2 emissions. So it's extremely sustainable. Many people think that filtered fume hoods aren't safe. There's a big misconception there. And the reason being is because we bring air back into the laboratory that we're conditioning, that we're working on chemicals at the source. Again, one of the misconceptions is, well, how can you guarantee safety? Safety is absolutely guaranteed with our filtration technology because we've been doing this for 57 years. I'm going to bring you over to the filtration columns and the stacks here to show you exactly how these are integrated. Sorry, I couldn't see myself on the screen. So again, one of the misconceptions is, well, you're bringing in polluted air, you're capturing it in the filters, and then how can we guarantee that what's entering that laboratory is safe? Well, Lab proprietary filtration technology and detection and communication capabilities, we have the ability to handle a broad range of chemicals. We have a primary filter layer, so that's our primary filter. We have a fan module system, and inside this system, we have sensing capabilities as well as communication capabilities. Then we have a secondary redundancy layer of filtration. What we don't see here is potentially a HEPA filter as a primary source of filtration, or a secondary HEPA filter in the event that these hoods are stored in a contamination controlled environment so that we don't compromise the integrity of the cleaner. Now, when we capture chemicals, we always want to capture it within that primary cartridge. We want to detect after that primary cartridge, and we want to have that secondary filter really as a buffer in the event that there's any breakthrough, but we never want breakthrough to exist. So the way we detect that is we have dry contact metal oxide sensors. We detect VOCs, formaldehyde, and or acids, or a combination of all three, depending upon the technology. In the event that we see a spike in concentration past this primary stage of filtration, we're detecting it within our sensors. And we guarantee that even at detection phase, they'll never be released exceeding 1% of the threshold limit value at the filter's exhaust. Now, how do we do this? Well, we have a list of over 700 chemicals we've tested under 6 different concentrations twice. It represents thousands of chemicals. Not only do we know what we can retain, we know down to the molecular gram of those chemicals we can retain before we see release not exceeding more than 1% of the threshold limit value. We also know our limitations. Our limitations are 13 chemicals. So those noble gases are those that are normally gaseous under normal temperature and pressure conditions. After that, the limitations are quantity of chemicals. What are you evaporating in that hood? How are you using your handlings? What is the quantity of the overall evaporation of your methanol, your chloroform, your hexane, your xylene, whatever chemicals you're handling? And we sorry, I don't know who that was. We have our customers fill out a completed chemical questionnaire, and we perform a feasibility study to determine first and foremost, is this product safe?
Hang on one second, Jesse, you got muted. I can't unmute you. No, no, I can't hear you. Are you able to unmute from your side? Hmm.
Is that better?
Yes, there we go.
All right, I don't know how that got muted. Apologies. So I don't know where I left off, Heather, if you could help me.
Oh goodness.
So it was testing. Perfect.
I failed my test.
All right, I'm going to start back on the feasibility study. So we have our.
You were talking about chemicals, the 15 chemicals that you.
The chemicals we can't retain. Okay, so I was talking about the chemicals we can retain, but more importantly, we also know what our limitations are, and it's 13 chemicals. Those that are normally gaseous under normal temperature and pressure conditions, or noble gases. After that, it's about the overall quantity of chemical that's being used. We can handle about 80% of the applications within laboratories today. It's really about overall volumes, and we work with our customers to help understand what that application is and reduce their overall volume and usage of the chemicals. How do we do that? We ask our customers to always, first and foremost, they have to complete a chemical questionnaire. It's a feasibility study. And it basically tells us the chemicals, the quantity of use, the duration of time, if they're heating that chemical, the type of container that chemical is in, how often the use is. And we take all that information and we perform our algorithms. We've assessed hundreds of thousands of different chemical applications. Again, doing this for 57 years, we invented this technology. So it's all we do. As you see, nothing is done. We solely focus on filtration. Then we take all of that information that the customer provides us, and we provide that feasibility study. Is filtered fume hoods applicable for use based on the customer's handlings? If yes, more often than not, it is. What is the overall life cycle of the filter? And we provide a guarantee. Typically, the filters last between 24 and 48 months. And throughout that guarantee, again, we have to provide a guarantee that there's never release exceeding that 1% of threshold limit value, but we have to adhere to 3 specific safety phases. Maybe I'll be able to talk later on today, but 3 specific safety phases. So you have normal operating conditions, which is what I just stated. Then you have detection phase. So you remember we have the sensors built into the fan chamber. So we're going to detect any spikes in concentration past that primary. And then we have safety phase. Now it's important to note that at detection phase, it's not at which point we're detecting 100% of the TLV. We're detecting at between 20 and 25% of the TLV at breakthrough of the primary filter's exhaust. And we do that very strategically because if we're 100% of the TLV, now this secondary filter is being used. And when you replace the filters, this filter no longer has the life cycle we guarantee. And then in safety phase, we have to guarantee that in the event that detection has continued to occur, so the alarms have continuously gone off and they haven't remediated, and then you have a spill within your fume hood, we have to guarantee that we're still safe and we still do not allow more than 50% of the TLV released at the filter's exhaust for 1/12 of the filter life cycle. Now, if you remember, I mentioned that filter being used, that secondary filter being used. It's important to note that when you replace the filters, the primary filter is the filter that gets disposed of, that gets removed. The secondary filter rotates down to become the primary. The new filter becomes the secondary. So that's the safety aspect of the technology and how the filters work and how we're able to guarantee your safety. First and foremost, if this product wasn't safe, then what good is the product at the end of the day? Addition to the fume hoods, now we know we have a hierarchy of controls. We want to separate you from the hazard. That's a contaminated containment device, an engineer control device, such as a fume hood. We have many different products, as you see, many different fume hoods. We have our standard, what's called as our capped air structure, single wall constructed fume hood. You have what we call a reversal sash. So not your standard research grade fume hood, but it does the job for the majority of applications. We also have partnerships with LabConco where they integrate our filtration technology above onto their superstructure called their Echo and Aero. And this gives you a traditional sliding sash. You have your gooseneck faucet, your sinks,
Sweet.
gas, water in the back. So there's a lot of different things you can do. Now, earlier I mentioned providing protection wherever the chemical exists in a laboratory. Well, as you see, we have a number of different solutions. Above me, that little device called the halo, hence the halo of light around that product. That is designed to mitigate the risks of fugitive emissions in a laboratory by providing continuous filtration and adding what's known as equivalent air change rates in your room. Sorry, somebody just asked a question about OSHA requirements. I'll touch on the safety standards in a moment. Then we have filtering storage cabinets, devices, and we have what's known as an integrated solution on flammable or acid cabinets known as the ChemTrap. This integrates onto any existing acid or flammable cabinet in your facility, and it constantly filters out the emissions in that fume hood. We know those are the most stagnant chemicals in a laboratory. When you open up those cabinets, you're inundated with emissions. Now, we know the EPA is setting strict guidelines, especially for DCM, methylene chloride, where
Jesse, you got muted again.
I don't know why that keeps happening. That's okay.
Sure.
Anyway, no worries. Here we are. So again, EPA regulations they're extremely strict, right? So today, methylene chloride, DCM, before they had a TLV 50 ppm or 25 ppm, depending upon the guidelines of the country they're in. Today, as of December of 2024, the EPA states that you can't be above 2.5 ppm. So we've got to do everything we can in the laboratory to reduce our risk to these chemical exposures. We have to go far beyond compliance. I've done seminars talking about OSHA, NIOSH, ACGIH, and the different levels of standards and the TLVs you can be exposed to, quote unquote, be exposed to for 8 hours a day throughout your working life. Unacceptable. We have to go well below compliance. Proof is such as what the EPA is putting in place now, and they're testing about 20 other different chemicals as we speak. So it's very critical to provide these types of solutions throughout that laboratory. Mitigate the risk of exposure. It's what we do. Now, all of our products also have what's known as smart technology, such as the light. That's our smart light technology. And that's an indicator, overall indicator of the product's performance. With the fume hoods, you'll see the light on the front of the fume hood here on our cap there, on the control module, on our LabConco, what's called GFH hood. And that's an indicator. Again, the performance of the hood. We're going to detect continuous phase velocity. We're going to detect the filter's performance. Have we detected any breakthrough? And then the overall mechanical aspect of the fans. Are the fans working appropriately? Have we detected a static pressure drop? One of those three things occur, that light will flash, followed by an audible to let you know the indicator of what may be failing, or not failing, but not providing you the most safe solution. On the halo, it's going to detect ambient air quality continuously. If we see a spike of concentration past baseline, that light's going to pulse saying, hey, we've detected a spike in concentration past your baseline, we're working to mitigate that solution. And then once mitigated, the light will remain steady again. Same on our storage cabinets. If the door is left open, filtration is detected as breakthrough of fan, all the products are going to constantly monitor and detect. Now, as far as safety guidelines that we adhere to, so it's CFA 9, ANSI Z95, AFNOR NFX 15 to 11, NFPA 45, 2019, 2024, 2015, 2009, depending upon what the AHJ is pointing to, and CSA Z316. We comply fully with all those standards, and those standards are mainly specific to fume hoods. Now, how do we comply with those standards? It's very important. Again, we have two different structures here, single wall constructed hood. Sash is a bit different than your sliding sash. It does not close all the way. So in order to comply fully with the NFPA 45 standard, you would have to go with the lab Congo structure because it has the fully sliding sash and the dual constructed walls. After that, it's really about the structure. Not every state points to NFPA as a standard they would like to adhere to. So again, many solutions through filtration. It's easy to install. There's no infrastructure cost. It provides a safer solution throughout the laboratory, and it's extremely sustainable. Again, why sustainable? Because we're keeping the conditioned air back in this very same facility that's typically throwing that conditioned air out. And Kathleen has a question.
Yes. How do you dispose of the filters? Like, do you have to have special equipment? Do you have to wear special gloves? That's had all the chemicals?
So quick question, standard PPE, and then the filter themselves should get incinerated. So we have contracts with Triumvirate, we have contacts with Clean Harbors, Veolia. Well, they'll take our filters and they'll send them to an incinerator. Now the customer can ship the filters back to us, or we can provide the service, bring the filters back, or the customers themselves have their own environmental waste stream that it would go through. But the proper means of disposal is through incineration. Now, we do create a zero carbon footprint within our filter manufacturing from cradle to grave. So the organic media inside these filters is coconut shells. We harvest the coconuts. We then use the husk of the coconut. We activate that coconut through high heat and steam. That's now activated charcoal. That activated charcoal then goes in the filters. The filters capture and contain the chemicals. We don't throw that pollution out into the environment and wasted air. Then that filter, once used, gets incinerated. These incinerators that these filters go into contribute to 14 megawatts of clean energy through steam, right? This steam and these incinerators have their own filtration where they have to comply with EPA 263 regulations, which means for every 10,000 molecules, only one can be detected at the exhaust or at the stack of that incinerator, much like our filters, right, at 1%. And every one of these filters themselves, when incinerated, contributes, this is a big filter, contributes to 73 kWh of energy. So it's a very clean process, again, from cradle to grave. And Kathleen has another question.
Oh, no, I don't.
Oh, you don't?
Thank you.
Put your hand down. Just kidding. Any other questions? I can't see all of that. I only can see screen one. So if there's any other questions, Heather, can you help me out there? Because I can't see everybody on the screen.
Absolutely. I know that there was one a few minutes ago, but I think you did explain it. Someone said, please explain TLV to make sure everyone understands what this means.
And to reiterate on that, just the threshold limit value, it's what you can be exposed to through 8 hours a day throughout your working life, so for 40 years. That's the threshold limit value that they say you can breathe and be exposed to. Again, that's the compliance. We've got to go well below that, such as, like I said, what the EPA is doing and cracking down on these regulations, as they should. It's factual information that the life of a lab technician who spent their life in a lab, their life is reduced by 10 years. It's like smoking packs of cigarettes. You can't see the chemical emissions, and most of people working in a lab can no longer smell it. Your olfactory sensor is wasted. It no longer can detect or trigger, hey, there's a problem. Therefore, you don't know there's a problem. That's the problem with air, the air we breathe, right? We can't see the majority of pollution. Yes, if you go outside in a city, you can see the haze, but inside, you generally cannot see air pollution. So we want to do everything we can to mitigate the risks associated with pollution inside of a lab and even outside of a lab. We have a whole comprehensive indoor air quality solution where we actually have sensing and software technology that will give you an overall wellness building score, how well and how healthy is your building based on TVOCs that we've detected, CO2, PM2.5, NOx, and we perform an algorithm to give you an overall building wellness score. It is critical. We wouldn't drink polluted water. Clearly, right? We need to treat the air the way we treated the water. Get the Water Act. We now need to have an Air Act so we can breathe fresh, clean air and be healthier. I've spoken to so many lab technicians over the years, and they've now experienced headache, rashes. They're now asthmatic. The list really goes on, and those are just the minor symptoms. It goes as deep as cardiovascular disease, liver disease, cognitive incapabilities, neonatal disease. There's a lot of things that the air causes within our bodies, and we must do better inside and out. We can't continue to dump out into pollution. Dump out and pollute the world. Sorry, I thought somebody was asking a question. So anything else, Heather?
How easy are these products to install?
Good question. So the hardest product to install is the Halo, and then I say hard, it's like a lighting fixture. So you have to tie it into the building's electrical. It needs to be hung from the ceiling with griffle wire or threaded rod. After that, everything else comes to the facility, with the exception of the lap combo hood. It comes as it is. This becomes a little bit complicated. Just make sure you have the proper width in the doorways. But the rest of the product you see here comes completely knocked down and can literally be set up and erected in minutes. You can build a whole fume hood within a half an hour. It's really that simple. So there's really no restraints as to where this product can fit within the facility.
You talk about energy savings. How is this quantified?
Quantified several ways. So we have a calculator. So we have to understand a number of things: the thermal load, the CFM, the cost per CFM, how many fume hoods, what's the total operating hours, and we perform an algorithm based on all of that information and give a baseline of what the savings is we think we're going to be able to provide, plus the CO2 emission reduction. After that, we've done several case studies. If you go on our website, Thomas can provide you with this information. We have several case studies proving that we've been able to provide facilities with LEED certification, ZNE. We end up being, filtration is the cornerstone to these buildings achieving these energy efficient marks. It's critical. Again, it's extremely hard to achieve, if not possible to achieve, in a fume hood intensive lab when it's all ducted fume hood. We've worked with Bristol Community College, first ZNE laboratory. They were going to design a high efficiency yielded lab, came out after they did their calculations and determined it's not going to work with ducted fume hoods. In fact, the hoods, 17 of them, just 17, was going to consume over half of their PV arrays. Hoods are very high energy use intensive products within the laboratory. It's fume hoods and it's -80s. Those are the two biggest beasts in the labs. And number one is fume hoods. Again, 3.5 times the amount of energy of the U.S. homes. That's what it equates to one ducted fume hood. And that will vary a bit if you have low flow hoods versus a CV hood, VAV. You're still throwing air 24/7. You're still throwing air, and air costs a tremendous amount of money. Not to mention if the hood goes down, how do you fix it? How do you repair it? How does somebody know? You have a low flow, your valve's not working right, you're not processing enough CFM, somebody's working in their hood thinking they're safe. Now you don't have a proper barrier, you don't have enough feet per minute. Now you have exposure issues. So there's certainly risks associated with both products, right? Ducted or filtered. You have to have proper administrative controls put into place.
How many halos would I need to provide adequate filtration for my lab?
Depends on the size of the lab. It's not a one-size-fits-all approach. Depends on the overall concentration of chemicals that are in that lab as well. But typically, it's one halo for every 500 square feet of space or 5,000 cubic volume of air we're looking to process. And that will provide you that one air change equivalency as per ASHRAE guidelines. So yeah, again, depends. We can come out, we do measurements, we work with the customer to determine the right amount of halos to provide the adequate solution. What are the capabilities to handle formaldehyde? great question. Yes, we can handle formaldehyde, and we handle formaldehyde quite well. We can handle about 220 molecular grams of formaldehyde before we've seen that release at 1% of the TLV of 0.75 ppm. So we have to be 0.00075, if my math's correct, ppm of detection of formaldehyde. So we can handle it, and we handle it quite well. And we have many applications using formaldehyde, especially histology and pathology facilities. And what you don't see behind me are the custom solutions that we have. These are all standardized products, but we can create completely customized solutions, downdraft tables, backdraft tables, larger walk-in hoods or floor-mounted hoods. A lot of different things you can do. Filtration makes that lab and makes everything possible. It's very versatile. There were a few more questions that came through. They came through so fast I did not read them. So Heather, if you can help.
Absolutely. How often do you need to change the filters when working with animals, hair or bedding? And are those devices not usable for such work?
So they are. So that would be a HEPA filter. And then the HEPA filters, you probably would have a carbon filter, not probably, you would have a carbon filter above the HEPA filter for the ammonias. But typically the HEPA filters would be changed out every 2 years, every year, again, depending upon load of contaminants, right, that HEPA filter is picking up. But the fan's going to detect a static pressure drop. Now we do have transfer stations, we do have bedding stations. Again, you don't see them here. Those would be customized solutions. As of right now, we're getting close to standardizing all those types of products. Good question.
What are the filters' capacity and how often do I need to replace them?
Capacity depends upon the chemical handlings, right? So remember that feasibility study? Don't know if I was muted at the time I talked about that, but it's based on that chemical application assessment form, and that will determine the overall capacity of that filter. It's what type, how much of the chemicals that we're capturing at a time throughout a year. Typically, it's 24 months on the carbons. HEPA filters, again, between 2 and 3 years. HEPA filters are much easier. They become more efficient as they get loaded. The fan just can't handle the pressure drop. Carbon filtration is much more challenging. They do not become more efficient as they become loaded. We certainly don't want any breakthrough. So it's a very delicate balance of how much air we process through those filters, how much chemicals we're putting through those filters, and again, what the exposure rate is past the filter's exhaust.
All right, I don't see any more questions, but I do want to take just a moment, and if anyone has any more questions, feel free to type them in the chat while I just show this real quick. All right, so just so you guys all see, we have a lot of the literature that Jesse's been talking about, as well as some web links to each of the products and some videos of how those are all working, and it will be on demand within 24 hours. So feel free to come in here and check it out after. And I'll hand it back. It doesn't look like there are any more questions now.
Excellent. Well, I think we spot on, right? We used our time. So again, just did it a little differently. Didn't want to do death by PowerPoint. Sorry for the continuous mute. I don't know. My controller does not have a mute button, so whatever, it doesn't matter. Certainly ask questions, reach out to your Thomas rep. Really to summarize everything, safety through filtration and sustainability. That's really what we do and have focused on it for well over 55 years. So we are the experts in this technology and would be happy to have further conversations with anybody that's interested. Thank you.
Thank you so much, Jesse and Erlab, for joining us today. I hope you all have a great rest of your day. Enjoy your weekend.
Thank you, Jesse. Great job.